Hi, yes, good morning, everybody. So yes, my name is Nick Devine. I'm an innovation engineer with National Grid Electric Distribution, and I'll be introducing the Shifting Currents project before handing over to Gary Swandles from Smart Grid Consultancy to talk about what we did and what we learned. So if we can move on to the next slide, please. So quick agenda today. So I'll be taking items 1 and 2, doing the introductions and the problem statement for what we were trying to address. And then Gary will carry it through to review of what we did over the project and then looking ahead to what we want to do next. Next slide, please. And again, please. So the project team, so we had National Grid Electric Distribution as the network lead, was supported by UK Power Networks in this endeavour as well, with a variety of water companies involved, so Anglian Water and Severn Trent, and have had our historic relationship from South West Water as well. And Smart Grid Consultancy were delivering the main volume of work on the project. Next slide, please. So onto the problem statement. So Shifting Currents is actually a follow-on from a Network Innovation Allowance project. So that we did preparatory work that brought us into SIF. So the Flowers project was a sort of cross-utility challenge to identify where the operations of each utility, electricity and water, could be more sympathetic to the other, and sort of unlock shared net zero benefits through the flexible operations of water networks. So we sort of calculated how this could be possible with a number of assumptions and identified use cases and methods largely around the timing of pumping of water. So we're talking about both drinking water and wastewater here, and how the timing and really the latency in that, in terms of, for example, pumping drinking water ahead of use could be used to shift electrical demand in ways that are sympathetic to the electric water network, and so unlocks net zero benefits for both electricity and water companies who largely share the same customer base. We established some base principles from Flowers, which was just a feasibility study, but we needed to test their replicability across the country and sort of demonstrate the value with a real world trial. So this is why we aimed the project at the Strategic Innovation Fund. So to talk about what we actually did in this project, I'll hand over to Gary now.
Thank you, and good morning. Can we skip a couple of slides to the art of the possible? So looking back at, we had a slight advantage over many of the other projects in SIF, in that this is a follow-on to an NIA project where we were challenged with establishing the art of the possible. That was done through engagement with South West Water and understanding many of the challenges that they have, some of them based around net zero and the difficulty that they will have in achieving net zero without some dramatic change to the way in which they operate. So in order to investigate that more fully, we looked at across the nature of their business. It clearly has very high demands on the electricity network, and as well as that, both being regulated businesses and utilities, there is I'd be cautious to say it, but there's almost a sort of socialist approach to the benefits that can be achieved from working with across the whole utility system. Then advantages and benefits can be achieved, which are then received by all customers, which in respect of these two utilities reflects most households and businesses across the country. So looking at the art of the possible, we did a desktop study, and what we did is we looked at quite a number of their sites, both in the clean water and in the wastewater, the streams, and also looked at potential of future electrical loads, such as EV charging, because there will be a big drive within the different water authorities to move their electricity, move their vehicle movements onto electrical systems as well. And that in itself will undoubtedly have an impact on the distribution networks. So looking at this, we gathered data from many of the sites that they have and investigated the latency that they have and looked at it in accordance with the flexibility services that are already being run by the distribution networks. However, we were very conscious of the fact that flexibility programs have been around for quite some time now, yet in spite of the potential that the water companies have, there's a very limited amount of that flexibility actually operates within any of the existing programs. So rather than just looking at the identification of flexibility, probably the more disruptive element of the previous trial, and also what we're looking at Shifting Currents, is identifying the potential of alternative incentives in order to encourage the water companies to work within the flexibility requirements the electricity networks have. So we've already developed quite a number of use cases, 16 in total, which capture the flexibility that's on offer within the different the different industrial processes they have, as well as the potential future consumption profiles from electric vehicles, etc. Can I skip forward a slide, please? So in the process, we looked at taking the outputs that we already had with the use cases and establishing, first of all, whether those were localized to South West Water only, or whether those can be achieved right across the water networks. And probably some of the key factors are whether the industrial processes are different, driven by the topography. South West Water is clearly very different from some other areas. If we look, for example, over to Anglian Water in the east of the country, the land is far flatter. So the processes of treatment and pumping, etc., do have significant differences. But going through the process within Discovery, we took these use cases and captured data from quite a number of for quite a number of the sites across all of the partners we're looking at, and carried out a similar technical assessment in order to establish whether the art of the possible and what we were hoping to identify within the NIA trials actually transpire through to a wider geography and a wider area of the market. So coupled with that and identifying that indeed, we've not seen anything conflicting with the assumptions that were made from the previous project Flowers, and it's worth noting that the closed down reports are all published from Flowers. So if you're interested in finding out more about the detail of the industrial processes that we're looking at and the latency that has been identified, those can be read in the Flowers outputs. However, looking at the processes that are there, they're very similar, albeit in different volumes and depending on the topography. But looking at the technical assessments, that would determine that there is flexibility there. But realistically, the biggest push that we're going to have is looking at the alternative mechanisms of rewards. And in those cases, what we're looking at is the potential of helping the water industry get more renewables online, closing the gaps between the control rooms, which largely operate independently of each other, but with a greater understanding of the challenges, is actually shifting the latency into periods where there's flexibility challenges for the electricity networks. But rather than pushing that into a system where it can be relatively transient, and there's the opportunities to generate income are sometimes not long-term enough for the way that the water industry itself does its budgeting. So looking at alternative mechanisms that would, first of all, help them in acquiring more renewable generation, which in turn would help with their net zero targets. Can we move on to the next slide, please? And I'll just touch on project conditions. Oh, so I'm sorry, if we could, I've already talked through that process. If we could go to the, yes, so yeah, if we, from the Flowers project, there is quite a significant value that we identified. We've tried to extrapolate that out as to the potential that may exist across the country as a whole. Within Flowers, we identified anywhere between 18 to 34 megawatts. The variation is due to seasonality and also some level of investment that would be required in order to release that capacity. But based on them only having 2 million customers and 18 to 34 megawatts of capacity, if that's then extrapolated out to the UK population, and I appreciate for the discovery phase, this is a very rough method of extrapolating out the benefits. But what we could be looking at is anything from half a gigawatt to a gigawatt of flexibility on offer from the water industry as a whole. Using the figures that NGED themselves have for procuring electricity, that could be as much as a £5 million benefit to the electricity distribution as a whole per annum. If we could skip to the next slide, please. So in terms of moving forward and within the going from discovery to alpha, realistically, what we're looking to do is within discovery, we've confirmed that the practical approach is the same, but as yet we've only really done this at a desktop level. So if we're moving through into the alpha phase, what we're looking to do is identify the best sites across the partners that we're working with, and from within that is actually carry out some full operational trials on each of the different site types, be it wastewater or freshwater, or drinking water, I should say, and actually establish whether the desktop analysis and the assumptions that are made therein can actually be achieved in proper operational outputs. And that will also include starting to look at the methods by which communications would take place between the control centres, looking to the regulators to engage and discuss different mechanisms and different alternatives for incentivizing that take them outside of the current the markets that are developing. And then also, if we're looking to encourage the behavioural change at a local level, is also to understand how the carbon is calculated, and moving away from using average carbon from the total consumption of electricity as a whole, and identifying the actual localized carbon impact of shifting around the load profiles in order that they can achieve better efficiencies for within the networks. I recognize that I'm running out of time here, so if we could skip forward to the slide around project conditions. That's one. So we were set project conditions at the start. There was three main project conditions that we needed to make sure that we were in support of, and there was no significant conflicts. The first was a review with the electricity markets, the REMA review that's taking place, and within that, actually, there was not only did we find that there was no conflicts, but there was actually a number of positive coordination with it. Moving on to looking at the other SIF projects, there was a couple that were flagged as could impact because of their interests within the water industry as well. Most specifically, the next gen electrolysis, which again could be looking at introducing some new but highly latent loads within the water industry. So if both projects were to go forward, those connections have been made and the coordination will be done. And then finally, to engage with Ofwat, particularly around their innovation teams, to flag this as a potential area of investigation and innovation, and ensure that they were happy and on board. And indeed, they have stated their interest, and if the project goes forward, would be brought on board as a stakeholder. I think that's probably, as I'm tipping over into 14 minutes, probably a good point to stop for questions, Manu.
Thanks, Gary. I mean, you did start a little bit early, but you finished, I think, a little ahead of time. That's no problem at all. And maybe through the discussion, you can bring out any points that you may have wanted to cover in the presentation. So yeah, if maybe ask Nick to come on as well. So I think I can't see any questions yet, but as I was saying, I think this is a great example of a cross-sectoral project, and I think a great way to start this session. So a few questions to start off with, just in terms of the kind of flexibility that you can potentially unlock from the kind of water pumping and other assets. Have you done any analysis on how this compares to cost of flexibility from other assets? Is it more cost effective? Is that one of the key reasons of kind of potentially pursuing this?
Well, the first thing is there's a lot of it. It's relatively well distributed, and obviously with serving the population, what we tend to find is that there's a good correspondence between where the electricity networks go, where population growth or industry is driving electricity usage is quite similar with,
so
with water.
I'm on the show and tell. I'm not speaking, obviously, but
okay, not sure who that was.
No, I can. Hold on.
Can somebody mute Jonathan, please?
Yes, your assistance, Jonathan. I'll carry on.
Sorry, Gary, go on.
So yeah, first of all, there's quite a lot of it, and it coordinates well. The big issue we have there is not so much around the price of it; it's the fact that the price that's on offer hasn't motivated large volumes of the water industry sites. So what we're actually looking at it is more from the opposite end of what do we need to do to enable it. What we don't want to do is just put an open check book out, because that really would be significant market distortion. What we're looking at here is actually trying to find alternative mechanisms. So indeed, in OPEX terms, we would like to see the flexibility on offer for £0, and actually. Again, I'm quite cautious to use the term quid pro quo, not just because it's difficult to say, but because essentially what we'll be looking at is a situation where the flexibility from water companies would be embedded first, ahead of then going out to procure anything else, but obviously finding other more appropriate benefits that would motivate them to be involved, but ones that are deemed acceptable as to the regulators, doesn't inhibit other providers.
Understood. So just to summarize, Gary, so there's a very high coincidence, technical coincidence, and there's a lot of confidence that they would kind of have the type of flex, and also they would have it during the times that the system might need it. But there are some potential structural issues, and therefore there is a broader UK PLC benefit of addressing and removing those barriers, so that such a large amount of flexibility is available, on top of which other sources could kind of build off of. That's the thinking. Is that right?
Your summary was far better than the original answer.
No, I can't.
And just to add on to that, I think the sort of like, when you're looking at it from a whole system UK PLC perspective, is that we are regulated utilities. We're not doing this with any kind of person. It's thinking of that water companies, electricity companies are both delivering services to largely the same customers. Most places have electrical and water connection, so it's a benefit which we can sort of stack together with that same customer set.
Got it. Thanks, Nick. And just picking up another point that you mentioned, Gary, which is motivation, which I found really interesting, because it feels like for projects thinking of, we as SIF want to see more cross-sectoral projects, and that aligning motivation is actually a critical point. Like, can you align on what they want and what you want? Otherwise, it's quite difficult to make that work. From your work so far, how much is kind of carbon reduction versus cost or kind of revenue generation a motivation has been for water company? Why are they kind of doing this?
So that's a really good question, because that actually takes us right back to the very first conversations of why the Flowers project originated, and that was through speaking with the heads of energy at water companies, and their challenge is significant. The net zero targets are really difficult, because for many industries, the carbon is a result of their own production processes. But to put it in quite impolitely, every time any of us flush our toilet, we are exporting our CO2 to the water industry to deal with. So it doesn't just have to take its own production processes and get those to zero. It's actually got to do a vast amount more, whether that be through offsetting, whether that be through renewables and exporting electricity. The net zero challenge is it's maybe not significantly harder than every industry, but for the majority of industries, their objective is a lot harder. So it's absolutely carbon was the original trigger, but looking at it across the board, the benefits are multiple, and not only that, the type of flexibility we're looking at from them isn't about firing up a gas engine or a diesel engine. It really is about taking processes that need to happen anyway and just doing them in a far more optimal fashion.
Understood. Thanks, Gary. I guess a little bit of follow-on question from that. I guess there is going to be revenue benefit for the water companies from doing this. As you said, it's not going to be a zero cost flexible. They're going to potentially participate in the market and provide flexibility to you. Is there any thinking on potentially how that value gets distributed back to water consumers?
Yes. So I mean, ideally, what we would like to see is, because of the closer ties that would occur between the two control rooms, sharing of understanding around operational requirements, process scheduling, etc., that would enable us to have a far more active understanding of what they're doing and relationship. And certainly one of the expressions from the water industry would be being able to get an awful lot more renewables onto the system without having to put expensive A&M systems, etc., in place. You know, I appreciate these are the challenges for the project, and so we're not at this stage making that proposal. What we want to do is make it fact-based, so understand that, and that's part of the next phase of the project. I'm sure it will come up with accusations of distortion or queue jumping within enabling connections, but just putting that aside for the moment, as difficult as that is, what we would want to see is the whole system efficiency. First of all, reducing costs. If they can get more renewables on, it will reduce their overall energy costs. It will also reduce the flexibility costs that would otherwise have to be procured with the market. So we would hope that would transpire through to reduced operational costs in both water and electricity, which would be seen through through lowered water rates. It would be seen through lowered GEOS costs, as well as the UK PLC net zero contribution as well.
Got it. Thanks, Gary. I mean, it's really fascinating. I think this kind of cross-sectoral thinking and how we can kind of overall optimize the system for kind of, you know, for consumer benefits. I have a lot of follow-on questions, but I'll hold off because there is a question from the audience. The question essentially is kind of linked to something that we've been talking about. I think you mentioned, which is the kind of technical compatibility. How does the locational and dispatchability of flexibility from the water sector compare with other forms of flexibility, like, you know, EVs or demand side response from homes, buildings, or electrolyzers? And I guess there's a question on likelihood of it being reliable and cost competitive. I think we've covered these points, but maybe just summarize. That's okay, Gary.
Yep. So there's it's not just a single asset type we're looking at. There's a number of industrial processes, and that's the reason we've got 16 use cases. Some of them ranging from almost an arbitrary shifting of processes that were set up in the past to operate during a fixed window, or quite simply through two set points, an upper and lower pumping set point, and they just have is actually bringing those in and managing them, and in some cases that would mean that they would just change their behavior now and into perpetuity, but that shift would reflect more so the demands on the electrical network, which was never a consideration when the profiles were originally set up, through to some other stuff which is more dispatchable, is for shorter duration, and is generally in a higher capacity delivery. So there's not just one shape of flexibility for going forward. There is a range, and they do different things. But what I would like to see, certainly within if we get alpha funding and support, is actually to look at probably the first 6 or 8 of those, which are less so in the dispatchable, but more so in the embedding. And what potentially happens there is it pushes back the time at which you then need to go to the wider market to procure flexibility in, because what you're just trying to get is conducive behaviours out of some of your highest demand customers on the network.
I think, and also just to add to that, I think this question sort of quite neatly articulates what the challenge of alpha and beta is we need to have a fact-based proof of what the reliability and competitivity of that flexibility is. We have some assumptions about the sort of dispatch and locations. We need to prove those through the work in the alpha and beta. So that is very much what you're attempting to articulate through the rest of the project.